open and closed state. So open and closed, only these two things you are going to sense. So therefore it is considered as a digital input device. So how to read the signal? This is the syntax what we have used called digital read of particular pin number. So the pin number, all the digital input output pins, we can use it. Okay. Then what we have to do, we have to read the status of the particular pin. Then we have to store it into the any one variable. Then checking the variable status. Say example, this digital read function will return some logical value. The logical value may be either 0 or 1. So by comparing that logical value, we can do our desired function logic in our program. So as far as the pin is concerned, either we will connect input device or output device. If you are connecting the output device, we will use the syntax called digital write of pin number comma the value. If it is the input pin, I will read the status of the pin using the command called digital read of only the pin number. Okay, because the logical change will happen in the external environment. In switch interface, we have seen that to avoid this floating state problem, we are going to interface on resistor called that is pull down resistor, making the port pin permanently to logic low. So whenever we are making the switch to close, at the time only my port pin will receive logic high. In this way, you can sense the external environment. Okay. Then this is our exercise. Using this exercise, we interfaced one switch and LED. So this is our interfacing diagram. This is my resistor and LED. So whenever I make the switch to turn on, at the time only the lamp will get turned on. Okay. If I make the switch to off, immediately my LED will get turned off. So for these two exercises, we have already sent the record material and prerequisites questions also. Try to attend, then you will get more clarity in this exercise. So for that, what we are going to do, we are going to read the status of the pin. For that, we are going to configure one pin for switch, another pin for LED. Then by default, we will make the output devices off in the void setup once. Okay, so this is the equivalent code what we are using in the Arduino. Then in loop section, we need to read the status of the switch. If the switch status is high, I need to turn on the LED, or else I need to turn off the LED. So this is the exercise what we have did in the last class. So please make note of these things. See, whatever the thing you have learned in the basic C program or advanced C program, those things you can utilize it here. Only the hardware knowledge as well as the syntax used for the particular hardware you need to learn. In our case, the first one is Arduino. So what are all the syntax we used in the Arduino? We will see one by one. Then we will make use of those syntaxes. Then by using our C program structure, we can start do a number of exercises. Okay. So this is our exercise. Here you are going to check the status of the switch. That is, switch is connected in pin number 10. If the logic is high, we are going to make the LED to on, or else make the LED to off. That's all. This is regarding our previous class exercise. And here we are going to give one task. Please make note of it. Actually, we're supposed to show this particular task in the last class. We are unable to show this task. So now you take down the task. It is very simple domestic application. So please observe the animation, what I am going to show here. Ma'am, is it visible, ma'am? Shall I continue, ma'am?
Sir, continue, sir.
Yes, ma'am. Yes, ma'am. Okay. See, please observe the animation. The task question is available in the animation form. So here I will give you the outline of the structure. This is our main switch. As like in our domestic wiring, first we will have the main switch nearby your energy meter. Then here we are going to consider only 2 rooms in a house. The first room, 1 lamp and 1 switch. In second room also 1 lamp and 1 switch. How we are going to control means, whenever my main switch is on. And if I make the corresponding room light to make on with the help of the corresponding switch, my lamp will get turned on. So here you can use the LED. No need to bother about this incandescent lamp and all. You can use the LED in our exercise. First room I made the switch to on. So therefore, sorry, second room number 2, I made the switch to turn on. The LED, the lamp gets on. Again, I am making room 1 lamp to on. Then, if I make the room 1 switch to off or room 2 switch to off, the corresponding LED will get off. Then, see, here you observe one condition, the individual switch having the lamp control. See, but the main condition, my main switch must be in on state. First, my main switch is on. Then, if I make the corresponding switch to turn on, the particular load will get turned on. Okay, I am making room 2 lamp to off. Now please observe, my room 1 lamp is still on and room 1 switch is also still on. In that condition, if I make main switch to off, all the lamp must be off. Okay, so the main switch have the master control. The main switch have the master control. So how to write the coding for this? Can anyone list out how many input and output devices required for this exercise? Can type it in your chat box. How many input and output devices required for our given exercise? Can you type it in the chat box? By reading the animation of the exercise, can you tell me how many input and output devices required? Can you type it in chat box? I'll unmute yourself and answer it.
So they are
How
saying
many
three
input
inputs and two
devices required?
outputs.
Very good. 3 input devices and 2 output devices. Out of 3, 1 is the master control. Okay. So I think you can write the simple coding for this exercise. Try to implement it. As we told already, beyond your exercise, we will give a number of additional questions. Few questions we will solve in the class itself. Few questions we will give in as a task. Try to practice it, because during examination, this kind of questions only will come. And also whenever you start do the project, your real scenario will appear like this. Okay. Then, now we are going to see one more concept in the switch interfacing, that is called bouncing. So what is mean the bouncing? So by viewing the animation, so the object trying to fall on the particular mat, due to the back effect, are there, as per the Newton's third law, every action have equal and opposite reaction. Likewise, due to the force given in the particular mattress, it gives the opposite force in the opposite direction. So the same kind of effect will happen in our switches also. So there are two concepts. One is bouncing. Bouncing is the phenomena. Bouncing is the phenomena. Before that, where it will happen? This bouncing phenomena will happen whenever you will start interface your push button or tactile push switches. Okay, push button or tactile push switches. In these conditions, we will come across the scenario called switch bounce. Switch bounce is the phenomena. Okay, why it is happened? See, if you observe the push button diagram, right hand side of your slide, inside you may observe that you have some mechanical arrangement. These are all the mechanical arrangement available. These two are the contacts, and also you have one spring. So whenever if you press the button, once you release the finger, the object has to come back. How? When it will come back, the spring effect will make your contact to make to original position. So this spring will lead you the bouncing action. So how to avoid that? How to avoid the bouncing action? For that, we are whatever the setup you are going to arrange it called debouncing. Okay, how we will arrive the debouncing, and also we will see this phenomenon in the little more way how it happens. See, here we are having one diagram. The pin number A is I am going to connect into my Arduino board. Already I have connected pull up resistor. So the pin number A will receive logic high all the time. If I make the switch to close, that means these two will get contact, thereby logic 0 will pass through my Arduino board. But if you use the push button like this, what kind of output you will receive means this kind of output. It may not go to zero immediately due to the spring action available here. It will lead you to bounce the contact. So these contacts will get bounced. Therefore, you won't get the steady state zero value immediately. Your output will get bounced like this 10 10 like that, get oscillate. After some time, it will get settled down. So how to avoid that? If you are writing the program to read the status of your button, here we are going to check only the logical change, either 1 or 0. Please think, if I read the status like this kind of input means, it will give the wrong information to my controller and it will consider multiple high and low inputs and it will make some undesired outputs in my output peripheral. So how to avoid that? It's very simple. How to avoid, we will see later. I will finish few more concept in this bouncing concept. Here, see, this is your TTL logic. This is your CMOS logic. In our Arduino, we are going to use the TTL. So transistor logic. So whenever you read the status, the logic will be considered like this. 0 to 0.8 volt is considered as logic low. 2 to 5 voltage is considered as logic high in case of TTL. In case of CMOS, 0 to 1.5 volt is considered as logic low. 3.5 to 5 volt is considered as logic high. For a moment of time, you ignore this CMOS one. Please consider this alone because this is the logic we are using in our Arduino. So consider this is your setup. So here you are making your push button to turn on. At that time, you will get the output like this. So this will happen in two things while the transition beginning at the same time at the end. Okay, so this will lead you number of on-off signals. It will give the number of on-off signal into your controller. How to avoid this? How to avoid this? That concept is called debouncing. So these are all the ones and zeros. See, if it is a exactly, if you push button is pressed and released, the required output is 1 and 0. But due to bouncing, you are getting number of ones and number of zeros. After that, you are getting number of one. Like that, you will get some false logic. So how I am going to avoid this? There are two things are available. One is the software solution and the hardware solution. Here we are going to discuss only the software solution. So how I can avoid? See, simply if you observe this waveform, after some time delay, I am getting the steady state output. So what we can do, instead of reading the output immediately, you can introduce little delay bit during this time. During debouncing period, using trial and error, you can find the time taken for this particular bouncing period. During that time, you can introduce the delay. The delay typically from 50 to 200 millisecond. So by using the delay, what we will do means we will ignore the bouncing inputs and we will consider only one press. Okay. So what is the advantage of this one is it is simple in nature and the only one disadvantage is it will block your remaining function because if you use the delay function, your microcontroller will pause for some time. It won't allow the other instruction to execute. How to avoid this scenario? See, this is very simple. Write digital read. See how to introduce the delay means write digital read of particular pin. After some time, give delay. Delay of, say example, 200 millisecond. After that, you read the value, accordingly you make the required output in your particular program. So after reading the switch, give some time delay, then you execute the remaining coding. But what is the disadvantage they given? It will block your whole function. That means whatever the function available in the program after this, it will get paused for some time. How to avoid this? This can be avoided using the timer based function called millis. This millis we will teach you later. At this point of time, please make note of this a particular hint alone. How to avoid this disadvantage means using timer based function. Okay, so in that you need to introduce little more coding. By adding little more coding, you can avoid the bouncing. Okay, wait. Now what we are going to do means, I will show a few things in the Tinkercad regarding the switches, because see, in this exercise, in this before getting into the new exercise, see, in this exercise you need to interface 3 switches. I will show you few more things available here in the Tinkercad. See, so these are all the switches available in the Tinkercad. Let me, already we have seen what is SPDT. Ma'am, is it visible, ma'am? Is it visible, ma'am?
Ah, sir, visible, sir.
Yes. See, this is your SPDT switch available in your Tinkercad. It has 3 terminals. Already in last class we have used terminal 1, then the common terminal and terminal 2. Okay. So there are 3 terminals available. These 2 terminals, common and terminal 1, are NC terminal. That means normally it will be in closed state. Okay. And similarly, the common and terminal 2 are NO. That means it is normally open. Whenever you make the slide switch to move from one position to another, it will start to work. Please see this. Please see this output. Please see this output. This is your switch available in this software. See here what I have did means, I have connected common and terminal 1. That means, see, these 2 contacts are normally closed. Closed means you will get the resistance as a 0 ohm. If I make the slide switch to change the position, it will get open. Can you observe NO and NC state? See, if I make the slide switch to come back again to the original position, these 2 will be in contact. That means 0 resistance. If I toggle the switch, it will get open. So if you are using these 2 connections, initially it will be in the closed state. If you make the switch to toggle, it will get open. But if you are using these 2 contacts, that means common and terminal 2 means what will happen. So this common and terminal 2 is normally closed. Okay, normally closed. So if you make the switch, see, initially it is in open state. If I make the slide to come to the contact with these 2, it will get close. Okay, so in this way you can make your terminal to function. Okay, so there are 3 terminals available. It is SPDT switch. This is the common pole. These 2 are, this is NC, this is NO. You can use any one terminal in your circuit. Most of the cases we will use this common terminal and this NO terminal. That means common and NO terminal, initially it is open. If we make the slide to move, it will get close. So in this way you can sense the switch, how it works in your system. Okay, the second one is the push button. The push button, just now we have seen push button. Usually the push button have 4 terminals. In this, see, there are 4 terminals available in this hardware, named as 1A and 1B, then 2B and 2A. Please observe, there are 4 terminals available in this push button. This is my 1A, this is my 1B, this is my 2A, and this is my 2B. See, how these switches are connected means, simply see, these 2 terminals, 1A and 1B, are permanently connected. In the same way, 2A and 2B also permanently connected. That means, you see here, if I start simulate, the resistance between these 2 terminals will be 0. The resistance between these 2 terminals will be 0. Here also 2A, 2B are permanently connected. Even if I press the push button, the logical level won't change. Then how we can use the switch? It's very simple. See, always you try to use the sidewise contacts or the diagonal contacts. See, if you want to use the push button in your project, you can use these 2 contacts. Say example 1B or 2B, or otherwise 1A or 2A. This is one method. How it works, check here. Now my switch is in an open state. If I press the push button, it will get closed. If I release the finger, it will get open. Okay? In the same way, if you use this 1A and 1B, 2A also, 1A and 2A also, initially it is open. If you press the button, it will get close. Okay, this is one way how to connect your push button. This is another way. Most of the time, it is advisable how diagonally you connect your push buttons. Say example, how to connect. See, this is 1B. The diagonal terminal is 2A. Here it is, see, here this terminal is 1A. The diagonal for this terminal is 2B. If you connect like this also, initially it will be in open state. If you press the button, then you will get contact. See here, if I press the button, you will get contact. Okay, the last one is your dip switch. So this kind of switches, you may use it in a number of applications. So what is the beauty of these switches mean? This is a switch, what you have seen in the PPT. In earlier PPT, you have seen this switches on this switch only. See, this switch consists of 4 switches within the single package. So in our today's task, you need 3 switches. So you no need to take 3 slide switches or 3 push buttons. You can take only 1 dip switch. In that you can use 3 contacts. How we can use it? See, it's very simple. Come here. So you have 8 terminals in this switch. See, this is one terminal, 1A. The opposite terminal is 1B. Then let me zoom and show you the switch very clearly. See, this is 1A. The opposite terminal is 1B. Then 2A, 2B. Then 3A, 3B. Then 4A and 4B. How we can use? You can use these switches simply. If you can give input in 1A, take output from 1B. Or else, if you give input in 2A, take output from 2B. Else, give input in 3A, take output in 3B. Or otherwise, give input in 4A or take the output in 4B. Or otherwise, if you are having more inputs, simultaneously, you can give individual inputs in the individual input pins and take the outputs from the corresponding pins. How it works? Let me do the simulation and check it. See, initially, all the contacts are in open. How to make the switch to close? Simply slide this contact. If you slide the contact from this off position to on position, the circuit will get closed. Now position 1 is closed. See, position 1 is closed. Now I am going to make the second position to on. See, 0 now. Then third position, then fourth position. That's all. So in this way, you can use your switches. In last class, we interfaced only the slide switch. How to use the push button and the dip switch is very simple. I will explain within 2 minutes. Please observe how to interface with your circuit diagram. Then it will be easier you to do the exercise using this kind of switches. Okay. Please wait until it gets uploaded. Yes. See, in this case, we used slide switch. You know how this particular program will work. If I do the simulation, if I make the switch to on, LED will get turned on. Okay. If I make the switch to off, LED will get turned off. How we are going to replace this switch with the help of the remaining switches? Okay, let me remove the slide switch. Then let me bring the push button over here. Okay. See, always you need to connect the push button in between the upper portion as well as the lower portion. In the middle portion only, you need to connect like this. As I told you already, I am going to use the diagonal contacts. Very simple. See, this is my push button. It has 4 terminals. Here I am going to use the diagonal contact. See, 1A, I am going to give the logic high as the input. And I am going to check the output in 2B. How it works? Please check. I'm going to do the simulation now. Start simulation. See, initially my LED is off. If I press the push button, my LED will get turn on. If I release the finger from the push button, LED will get turn off. Very simple. If you want, please take the screenshot of this one. Please take the screenshot of this circuit connection. How to interface. Always try to use the diagonal pins. It is very easier to remember. You no need to remember anything. If you give input, take the output in the diagonal terminal. Or else, if you give input here, take the output in the another diagonal. Okay? Then the last switch is your dip switch. How to interface the dip switch? It's very simple. Go to input components. Go to input components. See, you have two type of dip switches. One is the 4 switches. This is a 6 switch. Okay, let me show the demonstration with the 4. You can do the exercise with the 6. No issue in that. Okay, let me move the dip switch. And also the dip switch also must connect in between the top portion as well as the bottom portion in your breadboard. So this is the top portion, this is the bottom one. Connect in between the top and bottom. So here what I am going to do means I am going to connect the input in 4A. Okay, and I am going to take the output in 4B. Please observe, 4A I gave the input, 4B I am going to take the output. How it works? See, start simulation. See, now my slide switch in off state, LED is off. Make the switch to on. See, my LED is on. So in this way, simply you can interface the different kind of switches using Tinkercad software. Okay, that's all. So that's all regarding the switch interface. Now we will get into the new concept. So it's very simple one. Already you have studied this one earlier in your C program. Macro definition. Macro definition means what? As defined followed by the toString. So the first one is the constant name, what you are declaring, then the value. The value may be integer or any function you can write it. Okay. So here, how we are going to use this macro function in our Arduino hardware means, whenever you are declaring the pin number, you no need to remember the pin number, which pin number we have used for LED, which pin number we have used for switch. Simply you can use the macro function. In our case, LED, I am going to declare the pin number 13, and switch, I am going to declare the pin number 10. So if I declare this one in the declaration portion itself, I no need to declare the pin number once again. I can use this variable name LED. Okay, so if I want to make the particular pin LED to logic high means simply write LED comma 1 using digital write function. Okay, so this is the use of macro function. So you try to use the macro function in your exercises. It will be very useful. Okay. So it's very, what kind of mistakes you will commit means you may forget the space between these two. Okay, so you need to introduce the space between the as defined value, constant name. After that space, then you need to type the value. The value need not to be a value all the time. You can declare some function also here. Okay, very good. Okay, now we will come to the new interfacing device is called buzzer. So these are all different kind of buzzers available in the market. So these two are very popularly available. So this is PCB mounted type. So it will operate with the voltage of DC 5 volt plus 5 volt. So this is little bigger in size. The decibel value, that is a sound what we are receiving from this buzzer will be little higher. So this kind of buzzer only we are using in our two-wheelers and in UPS. Some of the domestic appliances we are using this kind of buzzer. So this kind of buzzers are used in the tiny projects. Okay, what is the difference? These two means the operating voltage. Here the maximum voltage is 5 volt. Here you can give the voltage up to maximum 20 volt. Based on the type of the buzzer available in the market, before giving the supply, you need to check the voltage rating, then you need to power up. Okay. So how it works? It is going to use the the principle of piezoelectric effect. You studied this one in 12th standard. Piezoelectric effect means if you give any mechanical input to the particular piezoelectric material, it will produce the electrical signal. See, this is the piezoelectric material available inside your buzzer. If you give any mechanical force, it will give electrical output. Okay. At the same time, if you give any electric input through this wire, it will produce some vibration. That vibration will be converted into the sound using some diaphragmatic technique available inside this package. This will make the vibration into the sound. Okay, thereby you can sense the sound from the device. For that, what we need to do, you need to apply DC voltage. Okay, then before interfacing the buzzer, we need to take down few more parameters we need to concentrate. That is your voltage and current rating of your port pins. You know already your port pins will capable of delivering logical 1 and 0. Logical 1 means 0 volt. Logical high means 5 volt. You know this one very clearly. So logical high means you will get 5 volt as output. Logical 0 means you will get 0 volt. So this is regarding your voltage rating. What about the current? This is very, very important. If you load your port pin with higher current rating devices, your particular microcontroller chip port will get damaged. To avoid that, you want to note down the current rating of the particular IC port pins. Here it is 40 milliampere. Okay. If you are drawing more current from the port pin, your particular port pin will get damaged. So the first thing what you have to note down is the DC per IO port pin means individual pin can capable of delivering 40 milliampere. Okay, that is the point number 1. Point number 2, the overall Arduino board can capable of delivering 200 milliampere. Please take down these two current rating. These two are very, very important. Whenever you are interfacing the device with your hardware unit, you need to take care of this. First one is for individual port pin. Say example, pin number 1, pin number 2, pin number 3, like that. The second one is for whole power supply. The whole input power supply, you can draw up to maximum of 200 milliampere. Okay. If I am going beyond this current rating, what we have to do, we will see in this class today. Don't worry. At this point of time, please make note of the current rating alone. Okay. Now we will come to the 5C exercise, interfacing of buzzer with Arduino. By interfacing buzzer, what I am going to do, it's very simple. Interface the buzzer with the port pin to your Arduino pin number. So let me use the same pin number as 13 and write a program to turn on the buzzer for 1 second. That means what? 1 second I need to make the buzzer to turn on. Immediately after the 1 second, I need to make the buzzer to off. How we can do it? Very simple. First, your interfacing diagram. You need to interface your buzzer with the Arduino. Straight away, you can't connect your buzzer with the Arduino. You need to use some driver circuit. So this particular portion is called as your driver circuit. Okay. So this portion is your driver circuit. With the help of driver circuit only, I can connect the buzzer. If you observe the diagram very clearly, here the buzzer is connected between your collector and emitter terminal of your transistor. I'm going to use the transistor as a switching device here. This is my collector terminal. This is my emitter terminal. So buzzer going to take the supply from external source. This is 5 volt. From the external source, it is going to drive and current will flow through the collector to emitter terminal. Okay. Then how I am going to trigger this? I am going to trigger this from my Arduino in the base terminal, IB. You may aware of that base current is always very much lesser than your collector and emitter current. Thereby I am going to save my controller by drawing extra current drawing from my controller. How I am going to protect this? Say example, my browser draws 30 milliampere. My browser draws 30 milliampere means this external source only delivers 30 milliampere. Okay, but my base current, it will be in microampere only, or otherwise few milliamperes. Thereby my microcontroller safe, it will drive only base current, that is my IB. The remaining current collected to emitter current will drawn from the external source. Okay, or otherwise the input power pin, from the input power pin you can take it, because the input power pin can handle up to 200 milliampere. Okay, so two ways we can do it. Either I can use some external source, or otherwise from the input pin, that power pins I can take it. Okay, how it works, let me see with the two diagrams. So the your transistor were working three regions all the time. The one is saturation, another one is cutoff, another one is active region. So if you remember the characteristics of your transistor, you may studied in your electronic devices classes. So here this particular region is called as a cutoff region. This region is called as your saturation region. What about this region? This is your active region. Okay. In this cutoff and saturation region, your transistor will act as a switch. What about in this active region? Active region, your transistor will act as an amplifier. Okay. Now you ignore the amplifier portion. Simply consider the cutoff and saturation. Cutoff means open switch. Saturation means closed switch. Very simple. So how we are going to achieve this? How we are going to achieve this? If you make this base terminal as logic low, your transistor will be in off state. Thereby my load is in off. This load, you can, in our case, you can consider this load as our buzzer. Okay, you see, in our case you can consider this load as our buzzer. Simply buzzer, my buzzer is off. If I give the logic high in this pin, what will happen? My switch will get closed, thereby my load will get turned on. In our case, buzzer. So buzzer will get turned on. It's very simple circuit. You need to use two resistors. One resistor. It is to limit your base current. The second resistor is your load. You no need to connect the resistor. This RL is nothing but your load. This load may be your relay coil or DC motor or your buzzer. Okay, but here also you need to take care of one thing. Whatever the load you are going to connect, that current rating you need to check with the data sheet of the particular transistor. If you refer your data sheet, they will give ICE, that is collector to emitter current, or simply collector current. The collector current, at any case, it should not, this collector current should not exceed. If it exceeds means your transistor will get damaged. Okay, so please remember your load current IL always lesser than your collector current. This is the hint. Say example, if you use BC547, I think the maximum current it can handle up to 100 milliampere. If you are exceeds that, your transistor will get damaged. Okay, your load current always lesser than your collector current IC. That is the important point. You need to note it down here. Okay, so to achieve this task, what we are going to do, the same blinking program. I'm not going to explain the coding. It's very simple. So may configure your any one pin as output. In our case, we are going to configure the pin number 13 as output. Then make the buzzer to turn on for some time, turn off for some time. So program wise, it's very simple. Only the interfacing is the important task. So come back here, come to Tinkercad. Here I will show you how to interface this buzzer with your exercise. Okay, the program, very simple blinking program only, we are going to use it. What we can do means, let me create new project. Let me take create new project. So, and all the time, whenever you submit your exercise, please mention the exercise number in your Tinkercad. Okay, then only it is easier for us to evaluate your observation and record contents. Okay, so whenever you use Tinkercad, please name the relevant exercise name in your project title. Okay, so interfacing of buzzer with Arduino. For that, what are all things we need? Can anyone help me? What are all the hardwares I need to fetch from the Tinkercad? Can anyone unmute yourself and tell? First, I need to take the Arduino. Okay. Hello, dear students. Can anyone unmute yourself and tell me what are all the hardware components I need to select? Hello?
Breadboard, sir.
Breadboard, very good. Then, then what else we need?
Buzzer.
Buzzer where we need to check, whether we need to check in the input device or output device. See output device, go there. There you will find your piezo buzzer. Simply drag and drop it over here. Okay. Then what are all the other components? What are the other components we need? Simply we are going, tell me.
Transistor, sir.
Transistor, very good. Transistor where we will find. Go. Slowly you go. See, power control. In this portion, see, let me zoom the screen little bit. See, here in power control, you will find the NPN transistor. Okay? Then, the last component is our resistor. That's all. That's all. So, let me show the terminals available in this element. Buzzer, it is positive terminal. This is your negative terminal. That's all. It's very simple. Only two terminals. For transistor, collector, base, and emitter. Okay. Now you recollect your circuit diagram once. Then with the help of this, we will start do the connection. Forget about the diode at this moment of time. Okay. So what I need to do? Emitter terminal, I need to connect it into the ground. Shall we do one by one? Okay, we'll do one thing. First, we will connect the emitter terminal to the ground. Step by step, we will do. Okay, let me pick the transistor and place it in the breadboard. Before that, let me power our breadboard using 5 volt and ground terminal. This is our 5 volt. 5 volt, 5 volt, yes, then ground. Ground. That's all, 5 volt and ground. Where is the emitter terminal? See, collector, this is your base, this is your emitter. Okay, emitter, we need to connect it into the ground. First point over. Okay, then come back here. Collector, I need to connect it to the one end of the buzzer. Okay, collector, I need to connect it in the one end of the buzzer. Where is the collector terminal? That too you need to take care. See, the top one is the positive terminal, the bottom one is the negative terminal. Okay, so the positive terminal I need to connect it to the 5 volt. The negative terminal I need to connect it to the collector terminal. Okay, so where is the negative terminal? This is my negative terminal. This negative terminal I can connect it to the collector terminal of my transistor. Okay, that's all. Two things over. Then what about the next one? Other end of the buzzer, I need to connect it to the 5 volt. So another other end of the buzzer, simply connect it to logic high. Logic high. That's all. Then only base terminal connection is remaining. How I need to connect the base resistor? So typically we will use 1 kilo ohm resistor. So one end of the resistor terminal must be connected to the base terminal. Another end must be connected into our Arduino port pin. So how to connect it? Take the resistor, connect it to the base terminal of your transistor, and there by default my resistor value is 1 kilo ohm, so no need to change anything. What about the another end of the resistor? Take the another end of the resistor, and connect it in pin number 13. That's all. That's all. Simple. Please go through the connection once. Please go through the connection once. This is your transistor. Collector terminal. One collector terminal is connected to the one end of the buzzer. That must be a negative terminal of your buzzer. Then positive terminal of the buzzer, I have connected into the 5 volt in the breadboard. Then base terminal, I have to connect it on resistor. Then the other end of the resistor, I need to connect it to the port pin of my Arduino. Then emitter terminal, simply connected to the ground. Now I need to make the buzzer to turn on for 1 second, turn off for 1 second. So for that, see, by default you are having the code as make the pin as output, then digital write off the particular pin number high, then delay for 1 second, then low, then delay for 1 second. Here what I am going to introduce as a new thing means, so whenever you are using any project, all the output devices what we are going to use in our exercise, in void setup, it must be in off state. Okay, make buzzer to off. Make your buzzer to off. Make buzzer to off. Okay. So initially by default, I'm going to make the buzzer to off. After that, on for 1 second, off for 1 second. Okay. Let me check the output now. Can you hear the sound? Can you hear the sound? Okay. That's all. That's all regarding your buzzer interface. Okay. So if it is a 5 volt buzzer, that too, it will take less than 20, okay, at the maximum, if it takes 20 milliampere means you can connect it to your Arduino put straight away. If it is a higher current rating devices, you must use this driver's element as your transistor. Okay. Don't forget to interface this one, or else what will happen? Your port pin will get damaged. Okay. So that's all regarding your experiment number 5C. Then we will take one additional exercise in this buzzer exercise. So far, do you have any doubt? Please interrupt me. Else, I will continue from here. Hello? Do you have any doubts so far? Dear students, do you have any doubts so far? Hello? Okay. I hope you don't have any doubts so far. Let me continue. Let me continue from here. Take the additional task, what is experiment given here. Read the switch status. If the switch is in off state, buzzer should beep. Okay, buzzer should beep means what? Turn on for some time, turn off for some time. It should not turn on continuously. Okay, so should not be continuous sound. Beep means what? Turn on for some time, turn off for some time. Okay, then what is the second statement? If switch is in on state, LED should on. How to do this exercise? What are all the hardware components we required? First list out the hardware components required. What are all the hardware components we required? We will list out one by one. Point number one, buzzer, first hardware. Then second hardware, switch. What about the third one? LED. Okay, three things we have chosen. Okay, then how to make the logic to work? What is the algorithm I need? How to do the thing? Very simple. Only two condition. If my switch is in off state, what I need to do? That is the first one. What about the second one? If my switch is in on, what I need to do? It's very simple. If my switch is in off state, I need to make the buzzer to beep. That means what? I need to make the buzzer to on for some time, off for some time. During that time, what is the status of my LED? Can anyone tell? During off state, what must be the status of my LED? Whether I need to make my LED to on or off. Can anyone type it in chat box? Or unmute yourself and answer please. If my switch is in off state, what must be the status of my LED? Hello? Hello? Can anyone unmute
Off,
yourself and
sir.
answer? Hello?
Sir, they are
Off.
typing off.
LED should be off.
Very good. LED should be off. If switch is in on state, what I need to do? I need to make the vice versa condition. That means I need to make the LED to on. I need to make the LED to on. Then what is the condition of my buzzer? I need to make the buzzer to off. That's all. Shall we do this exercise? Shall we do this exercise? It's very simple. We are going to interface only few hardware components in our circuit. Let me modify the same thing. See, let me take the same buzzer connection as such. We will include the LED as well as the switch alone we will include. Okay. For that, I am going to fetch one LED. LED is available in the output component. Choose output, LED. Then what? I need to interface one switch. Okay, shall I use the dip switch in our case? You will get familiar how we can use the dip switch and all. If we are using it to one or two exercises, you will come to know how to use this in and all. Okay. So switch, first I'm going to interface the switch followed by the LED. Okay. So switch, what we will do? So I'm going to use the Fourier terminal. So I'm going to make it into logic high. Logic high. Then in the output terminal, I am going to connect one pull down resistor. I'm going to connect one pull down resistor. So typical value of the resistor is 10 kilo ohm. Take the resistor and connect it. So one end of the resistor must be connected in logic low. Then only it is called as a pull down configuration. So pull down means make the resistor terminal to logic low and make your port pin to permanently logic low. Let me consider, let me use the pin number 2 as a switch pin. Okay, pin number 2. That's all. Pin number 2 I have connected to switch. Please recollect the diagram once. See, logic high given in the input, then in the output terminal of the switch, one pull down resistor, 10 kilo ohm resistor connected to the logic low, then the common point where the switch output terminal as well as the resistor terminal is connected, from there take on output and connect it to your where? Port number 2. Then I need to connect one more LED. Let me take the another wire and connect it here. Connect it over here. Name the wire, give the color coding, the different color coding. Okay. Let me give the pink color. Okay. So now you take the LED. So LED, this is my cathode terminal, this is my anode terminal. Okay. What we will do, we'll bring the LED over here. Then the cathode terminal straight away we can connect it into ground. Cathode terminal straight away we can connect it into the ground. Anode terminal Shall I connect to the anode pin straight away to my port pin? No. I need to use the current limiting resistor. Okay. So the value of the current limiting resistor, typically we will use 220 ohm. Let me change this wire connection alone. Let me shift the connection from there to here. That's all. Check pin number 2. Pin number 2 switch. Pin number 3 LED. Pin number 3 LED. Then current limiting resistor. Then other end of the resistor is connected to the anode terminal of my LED. Okay. Shall we start write the program? So here, let me use the macro function. How we can use the macro function? Simply use as define. I'm going to define all the pin numbers here. The first one is the switch. Switch pin number 2. You refer your hardware circuit. Switch we have connected in pin number 2. The second macro function as define. What is the second one? Is my LED. What is the pin number? 3. That's all. Then as define buzzer. We give the short name buzz. Okay. Pin number 13. Now, what I need to do? Point number 1, I need to configure input and output modes of the pin corresponding to its application. Okay. So LED and buzzer both must be configured as what? Can anyone type it in chat box? LED and buzzer. LED and buzzer are input device or output device? Can anyone unmute and answer? Hello?
Output device, sir.
Very good, very good. Output device. So LED pin mode output, very good. Then followed by the second one, buzzer. So buzzer BUZ, buzzer. That's all. Then switch. What about the switch? Can anyone tell me? What about the switch? Switch is the input device or output device? Very good. It's a input device. It's an input device. So all the main declaration is over. And also, I told you already, so whenever you are using this kind of exercises, all the output must be in off state. Off state means, in our case, if you make it into logic low, then only it will be off. So for that, what I'm going to do, I'm going to make first my LED to off. Okay, make my LED to off. Actually, LED abbreviation is always in capital letter, then or else you will read it as a LED. Okay, LED off, followed by your buzzer off. Can anyone share the remaining program in the chat box? Thereby, let me copy your code and use it for our exercise. Can anyone type your own code in the chat box? Thereby, let me take the code from the chat box and use it. Then you will get confident. See, whenever your program works, you will get confident. Thereby, you will trigger and you will start do your a number of exercise by your own. Can anyone type it in the chat box? If statement alone, you type it. Then else statement, we will modify it from there. Can anyone type the if statement? Simply. So pin numbers I have given here. Okay, else we will do one thing. I will type the program. You check with yours program. Okay. Int switch status. Let me take the variable name as a int switch status. Digital read off. What is the pin number? Pin number I no need to tell. Simply I can give the macro function value as SW. Read the switch status. Then immediately comparison statement. If my switch is equal to logic high, that is nothing but if my switch is in on state. Okay. If my switch is in on state, as per our problem statement given, If my switch is in on state, I need to make my LED to on and buzzer to off, isn't it? Go through our problem statement once and check it. If my buzzer is in on state, make the LED to on. Okay, so make the LED to on. How we can make the LED to on? Simply here you make LED to on. That's all. That's all. The second one, at the same time, I need to make my buzzer to off. Buzzer to off means what? Buzzer, comma, logic low. That's all. So if statement is over. What about the else statement? Else statement. In else statement, if my switch is in off state means, wait a minute. We have code window. Yes. See, in else statement, what we need to do? Type else. Else means what? My switch is in off state. Off state means once I need to make my buzzer to beep. Okay? I need to make my buzzer to beep. At the same time, my LED must be in off state. So first I will make the LED to off, followed by I'm going to make my buzzer to beep. Okay, buzzer high for some time. Let me give the delay as 500 millisecond. Okay, then low for 500 millisecond. Is it okay? Is it okay? See, we made the pin to input and output perfectly. Then we are going to read the status of the switch based on the same variable I need to use. Switch status equal to 1. That means my switch is in on state. My switch is in on state. Else means it is in switch is in off state. Okay. Shall we check the output now? Shall we check the output now? LED low. Yes. Start simulate. Minimize your code window. See, my switch is in off state, so buzzer beeps. If I turn on the switch, see, turn on the switch, LED on, buzzer off. Is it okay? Is it okay? See, and also you reverse the condition and check it once again. Switch is off, buzzer beep, LED off. Switch is on, LED on, buzzer off. Okay? Likewise, you can do your exercise by your own. For your reference, let me copy the code in the chat box also. That's all. This is not the only way. You can write your own logic and you can make your system to work. Then the next one is the relay interface. So how to interface the relay? I will teach you few theory content today. Okay? Regarding relay, can anyone tell me, have you studied what is relay? Can anyone tell me? I think Triple E students may know. So relay is also a switch, but it is an electromagnetic switch. Okay? It is an electromagnetic switch. It uses electromagnetic principle. How it works? What are all the... Ma'am, is it this new PPT is visible, ma'am?
Sir, visible, sir.
Yes, ma'am. Okay. Students, do you have any doubts so far? You can ask. Else, I will continue the relay portion. So relay, see here you have two parts. The one is the coil, another one is the contact. Okay. See, there are two parts in your system. One is coil, another one is the contact. Please make note of it. So coil is the one part. Then contact. How many contacts are there? 3 contacts. Okay. How it is named? See, NC, NO, common. This arrangement put together is called as an contact. Okay? Coil. See, this is your coil. How we are going to actuate your coil? We are going to give some external DC supply. If you give DC supply, external DC supply, you can energize your coil. Okay. So what are the two parts available? One is your coil, another one is the contact. How many contacts are there? 3 contacts are there. Okay. What are all the name of the contacts? One is NO, NC, and common. Okay. How it operates and how we are using it. See, here the below animation shows how perfectly the relay works. Where we are using relay in our domestic appliances, please find out. Next class I will ask where we will use it. Okay. So whenever the relay gets energized, this contact will move from one position to another. Okay. So this movement we are going to use it to make my output device to turn on as well as turn off. See, whenever my relay is in de-energized condition, my load will be in off state. Okay. Whenever it energized, it will get, load will get turned on. Okay. So there are 3 terminals I told you already. What are all the 3 terminals? We will see one by one. The first one, see that there are 3 contacts available. The first one, as we told already, C represents common. NC represents normally closed. NO represents normally open. Please make note of this one. Common, NC, and NO. Okay. Electronic student, as electronic students in our integrated circuits, that is your IC chips, we use the same NC as a notation. There we will spell it as no connection. Here you should not tell it a no connection. Here it is called as an normally closed. Okay. Why it is normally closed and normally open? Very simple. At rest condition, please observe, whenever my relay is in off state. Let me show the previous diagram also. See, whenever my relay is in energized state, it will be in one position. Whenever it is in off state, it will be in the another state. Okay. See, whenever my relay, let me check with the one more diagram. See, NO and C, off state and on state. Here it simultaneously happens. Else, off state, if you are getting off state alone, that will be good. Wait, let me check the off state alone. Yes, off state. See, whenever my relay is in off state, this NC and common will be in contact. Therefore, only it is called as an normally closed. Okay. You may clear that why it is called as an NC. Why it is called as an NC means at de-energized condition, common and NC will be in contact. Therefore, it is named as NC. That means normally closed. So normally it is in closed state. Okay. At the same time, why it is called as NO? Normally open. What are all the terminals is normally open? You need to compare with the common and this terminal. These 2 terminals are open in the off state. Therefore, it is called as an normally open. Okay. I hope you are clear with this. Whenever my relay is de-energized condition, that is in off state, this NC and common will be in contact. Therefore, it is called as normally closed. Okay. At the same time, this NO and common is in open state. Therefore, it is called as an normally opened. Okay. Now you come back here. You will continue this one. Yes. So these are all the name. How the name arrived, you know. How it works, very simple. Whenever you energize, this mechanical contact gets attracted. This mechanical contact have one lever. This lever arrangement is fixed with your common terminal. Whenever it gets energized, the lever will move from NC to NO. Okay? You can observe the animation very clearly, how the contacts moves from normally closed to normally open whenever it gets energized. Okay? With this idea, we are going to discuss few more things. Please make note of this. This relay circuit always have two circuits. Okay, one is the coil circuit, another one is your contact circuit. The coil circuit always it will take low current. Please make note of this. My coil current always will be in low current rating, but my contact currents will be in high current rating. During rest state, that means de-energized condition, this will be in open state. Whenever it is energized, it will get contact. This coil current will be lesser than your contact current. Why it is lesser? If you observe this diagram, the coil battery will supply only the current flowing through the coil. This will be in milliampere. Okay, but my contact current, please observe here, my contact current is going to drive my load. So based on the load current, this contact current will get vary. If my load, let's say example, if you put high watt lamp, my contact current will be very high. Okay, so always you are having two current path. One is the low current path, another one is the high current path. Okay, then driver circuit. So we have seen that directly we can't connect the relay with our Arduino board, because my relay coil will take more than 20 or 40 milliampere. Based on the relay configuration, it will vary. Okay, if it exceeds greater than 40 milliampere, straight away I can't connect it to my Arduino board. It will damage my port pin of my microcontroller. To avoid that, I need to introduce one driver circuit. Okay, so driver circuit is very simple. We are going to use one transistor as a switch. Whenever you trigger the switch, as like in the buzzer case, what we have used, instead of this coil setup, here we have used buzzer, isn't it? The same way, here we are going to replace the buzzer with the your relay coil. So the relay coil I am going to interface with my transistor circuit. So the relay coil will take the current path like this. Okay. At the same time, my microcontroller will feed only the base current. So in this way, I am going to use this relay interfacing. Then this coil, I need to connect it in the collector to emitter terminal in series. Collector to emitter terminal need to connect it in series with my coil terminal. One end of the coil must be connected in VCC, another end of the coil must be connected to the collector terminal of the transistor. Okay, base terminal we will connect it into the port pin of our microcontroller. Say example, Arduino pin number 13 or 12. Likewise, you can connect it into the any one port pin of your microcontroller. Then so this LED we have given is for indication purpose. If you want, you can add it. Then here we used one diode. This diode, whether this diode is connected in forward bias or reverse biased. Can anyone unmute yourself and answer? See whether this diode is connected in forward bias or reverse bias. Let me give the hint. This is your cathode terminal. This is your anode terminal. Okay, cathode terminal is connected to plus 5 volt. Means it is forward bias or reverse bias. Can anyone unmute yourself and answer? Hello? Whether the diode is connected in forward bias or reverse bias mode. Hello? Am I audible? Hello? Hello?
So reverse biased. They're saying
Yeah,
reverse
very good.
biased.
Okay, so reverse bias. So we have to connect to one diode in reverse bias mode. The function of the diode here, it is called as an freewheeling diode. This freewheeling diode is used to safeguard your transistor, that is your switching device. See, what for we are going to use it? To save your transistor. How it is going to save? See, whenever I make my relay to on and off, what will happen? The current flows through the inductor will get cut off, then it will come. Then it will cut off, then it will come. Like this, the current flowing through the inductor will get changed. You know one for formula that induced EMF. What is the induced EMF across the coil? It is the famous formula. You know that L into dI by dt. This formula you know. So this is as per the Faraday's law of electromagnetic induction. The induced EMF across the coil will be L into dI by dt. That means whenever there is a change in current, there will be an induced EMF in the coil. The induced EMF in the coil is directly proportional to your switching frequency. If you make your transistors to on and off with high frequency rate, the induced EMF will be in high rate. What will happen? The particular very high voltage, then if you turn on this transistor, means what will happen means this very high voltage won't disturb your system. Whenever it is in off state, at that time, whatever the back EMF in this voltage plus this 5 volt. Say example, the induced voltage may be 100 volt for moment of time. It may not be very long time, only very finite time. So it will give only 100 volt plus 5 volt. That means the collector to emitter voltage, now it will be 105 volt. Whether my transistor will withstand this very high voltage? No. It will damage your transistor. To avoid that, what we are going to do? We are going to use this freewheeling diode. So the induced EMF will be always, it will be in negative. That means it is opposite in nature. That's why only here 5, here induced EMF will be here. See, this is plus terminal means this is minus and plus. The induced EMF will be in 100. So 100 plus 5 will be 105 volt. Definitely it will damage your transistor. To avoid that, we are going to use this freewheeling diode. It must be connected in the reverse bias direction. If you are not having the diode in your circuit, what will happen? This induced EMF plus your this voltage will damage your transistor. As we discussed earlier, the induced EMF plus my input voltage during off state of the relay. On state, it will not damage my system because voltage across the transistor will become 0. During off state, it will damage my switching device. To avoid that, I need to use the diode. Now you please observe, as for the induced EMF, my diode will become a forward bias, isn't it? Now it is the positive terminal, this is the negative terminal. So whenever I make the transistor to off, at that incident, the induced EMF voltage will get discharged through this circuit. Okay, so it will freewheel the stored energy. Therefore, it is called as a freewheeling diode. Here, what is the takeaway point? Whenever you are using any inductive element in your switching devices like this, say example DC motor or relay, these components will possess inductor in it. Whenever you are interfacing the inductive element with this switching device, you must use the freewheeling diode. But that is the first point you need to remember. Then point number 2, whenever you are connecting the diode, it must be connected in the reverse bias mode. Okay, if you connect it in the forward bias mode, your relay won't turn on. Always this circuit will be in on state, your relay always will be in off state. Okay, you leave that point now. Right now, only remember the 2 things. Whenever we are using coil, use freewheeling diode and connect it in reverse bias mode. That's all. Okay, this is a summary regarding this. Then if you are going, you are going to buy the relay from the hardware shops, how you can interface this. At that time, you will find 5 terminals at the bottom of your relay. So what are all the terminals? Please take the screenshot of this one. These two terminal are coil terminal. The middle one is the common. These terminals are NO and NC. In few relays, you may have the symbols inside it. If you are having symbol inside it, you can simply connect your circuit, or else with the help of multimeter, you need to check the terminals, or else if you note down the pin terminals, you can simply give the connection to this relays. Okay. So this is your SPDT relay. Then these are all two different operating voltages, 5 volt and 24 volt. How we will find, in most of the time, you people buy the wrong relay. See, 5 volt DC means 5 plus 5 volt I need to apply. Here you observe, it is 24 volt DC. So this specification is related to your coil. So what is the voltage I need to apply across the coil is the operating voltage of the relay. Here we have given two specification, 5 and 12 volt. This you need to note down. Then this is the one specification. Within 2 minutes I will wind up. So please note down these points, very much important. First one is the coil specification. Then the second one is the contact terminal specification. What is the contact terminal specification? Say example, please observe here. In our contact terminal, what are all the terminals available? Common terminal, then NO, then you have a NC terminal. So we are going to connect some elements in these terminals. It is going to draw some current, isn't it? So here they are given two specifications. See, these two specifications are related to your contact terminals. Here these three are related to your contact terminal. What are the specification given here? What is the voltage you need to apply in this terminal and the current rating? Okay, approximately it will come in 10 ampere. See, in first case 250 volt AC, second case 30 volt DC, then 125 volt AC and 28 volt DC. Then corresponding current rating is given. In this relay, all the different voltages current is same, but here you will check for AC 250 volt 12 ampere, then DC 24 volt means it is 15 ampere. Then if you observe here, AC 250, in this they are having two different specifications. If you buy this specification, you need to follow this. If you buy this, you need to follow this. What is the specification gives means very simple. One is the coil voltage, second one is the voltage and current rating of your contact terminal. Very simple. Okay, that's all regarding this diagram. This kind of interfacing diagram we will do it in our exercise. See how we are going to control the lamp. Phase I am going to straight away connect it to the common terminal. Then from NO I am going to connect it to the one end of the lamp. Another end of the lamp I am going to connect to the neutral. Whenever relay gets energized, this common will get close with NO, thereby my lamp will get turn on. Okay, that's all regarding this relay interfacing. In next class we will do the exercise with relay. Do you have any doubts so far? You can ask, else you can wind up. Don't forget to finish your record and observation works. It is available in your Google Classroom. Go and check your content regularly, and whenever you find time, please finish your work. Okay, it carries 100 marks for each experiment. Try to finish it. Okay, that's all from my side. If you have any doubt, you can ask.